Welcome to a new unit, Unit 4, Congruent Triangles. Day 1, we're going to talk about classifying triangles, and we're going to focus on isosceles triangles and equilateral triangles. Here, as we classify triangles, you will notice that if we have 3 acute angles, it is called an acute triangle. If we have 1 obtuse angle, it is called an obtuse triangle. 1 right angle is called a right triangle. And if we have 3 congruent angles, it is called equiangular. Now, what I would like for you to know about equiangular is that if all the angles are equal, they're each measure 60 degrees. Okay? Because the total angles in a triangle is 180 degrees. We're to use a diagram to classify the triangle by its angles. We're going to start off with triangle CDE. So here we go. We have triangle C, go to D, and go to E. And we can clearly see that is a right triangle. So we're going to go ahead and write that in. Right triangle. We're going to take a look at B to C to E. Start at B, go to C, go down to E. I see 1 obtuse angle, so this is going to be called an obtuse triangle. The next one is triangle ABE. We're going to start at A, we're going to go to B, we're going to go to E. And what we notice is that we see 3 arcs. We have an arc, and an arc. That means they're congruent. So if each one angle is congruent, it's called equiangular. I like it because you see the word equal, and then it ends with angular. Equiangular. I want to take a look at triangle BDE. If I go from B down to D to E and then go back up to B, I could clearly tell that that is an obtuse triangle. Sometimes you have to sketch or trace along the triangle to be able to classify it. So we're going to take a look at triangle CFE. I'm going to start at C, I'm going to go to F, and I'm going to go to E. Some of you may want to say that's a right angle. However, when I go to C to F to E, it isn't a right angle, it's actually an acute angle. So we're going to go ahead and put down in our notes an acute triangle. Next, we're going to classify by sides. So we're not looking at the angles anymore, we're looking at the sides. And the very first one is called equilateral. That's equilateral. This one where we have 2 sides that are the same, or at least 2 sides, is called isosceles. And last but not least, we have scalene, when no sides are the same. Sometimes the markings will look like this. This may have 1 tick mark, this may have 2, and this may have 3 to represent none of the sides are the same. We're going to classify each triangle by its sides. We're going to start off with JKM. Take a look at J, go to K, and go back out to M. When I look at that, I can tell that no sides are the same, especially when I look at the markings of each one. And if no sides are the same, it is called a scalene triangle. We're going to take a look at K, L, N. Start at K, go to L, go to N. I notice that I see 2 tick marks here and 2 tick marks here. That means I have at least 2 sides congruent, and so this would be called isosceles triangle. At least 2 sides. Last but not least, we're going to look at J to K to N, going from J up to K to N. Every side that I passed had 1 tick mark, which represents that each side is the same. They're congruent. This type of triangle is called an equilateral triangle, classifying by sides and classifying by angles. This one is a U-tri. You're going to classify each by the angles and the sides. So you should have something like it is obtuse and it is scalene. So I want you to take a second to try these. Alrighty, go ahead and check your answers here, and hopefully you got those correct. And then we're going to move on. If you would take a second to try to label the parts of the triangle, and basically you can use a sticky note or you can use a pencil. In case you get it wrong, you can erase it. And what I would like for you to do is I want you to list or use the proper notation to list the legs, the vertex angle, the base, and the base angle. I'll give you a few seconds to do that, and then we'll work on it together. Alrighty, here we go. The two congruent sides, which are definitely called legs, they are AB and BC. There you go. And they are congruent. How do we know that? Well, it's isosceles, and it tells us that the legs are congruent when you have an isosceles triangle. Two legs are congruent. So here they are with the tick marks. The next one here, an angle where the sides intersect, is called the vertex angle. So here we have the vertex angle right here. B is the vertex angle. Or we listed it as angle 1. But you could have called it angle B. It would still be correct. All right, we're going to take a look at the base. Okay, so it's going to sit on the base. So the base is AC. That's called segment AC, as you see the notation right here. Now let's take a look at what we call the base angles. The base angles, of course, are connected to the base. So the base angles here, angle A and angle C, or you can call it angle 2 and angle 3. We're going to talk about the isosceles triangle theorem. And basically the theorem states that if two sides are congruent, then we can conclude that two angles are congruent. Well, which angles are congruent? Well, they're going to be the angles that are actually opposite the sides. Okay? We're also going to take a look at the converse of the isosceles triangle theorem. The converse states that, hey, if the angles are congruent, two angles are congruent, then we conclude that the sides are congruent. So these are the converse of each other. So if you start off and you know two sides are congruent, we definitely can conclude that the angles are congruent. On the contrary, if we start off knowing that the angles are congruent, then we can conclude that the sides opposite those are congruent. Now let's get some practice in to figure out how all this works. Here, we're going to apply our knowledge of sides and angles, and we're going to figure out these isosceles triangle. Let's go ahead and start with number 2. With number 2, I see the tick marks here. And anytime I see tick marks, I know that two sides are congruent, therefore, two angles are congruent. So what I'm going to do is I'm going to put an arrow, and my arrows are pointing away from 106, which means there's not going to be another angle that matches angle D. So what I'm going to do is I'm going to put an X right here and an X right here to represent the unknown angles. When I get ready to set up my math problem, I can say one angle is X, the other angle is X, and my third angle is 106. What should all of this add up to? You got it. It should all add up to 180 degrees. So we figure out that 2x here, when we combine like terms, 2x is going to be equal to 74, and when we divide by 2, we get that x is equal to 37. So now we know that this angle over here is 37 degrees, and the other angle is 37 degrees, because when we have two sides that are the same, we have two angles that are the same. So angle C is 37 degrees, and angle E is also, 37 degrees. Give you a chance. You go ahead and work out number 1 and number 3. See what you get, and you can definitely show that to your teacher. Moving along, we're going to take a look at number 7 and save number 4 for you. Number 7, I don't see any marking, so I don't know if it's isosceles. And then all of a sudden, I notice that I have two angles that are the same. According to the theorem, if I have two angles that are the same, then I have two sides that are the same. So 74, let's go across from 74 and show that this side is equal to, go across from 74, is equal to this side. So when I get ready to set up my math equation, I write 9x minus 73 is equal to 3x plus 23. You can hit pause at this time and work on your algebra and see if we get the same answer. We get x is equal to 16. This one we start off with a word problem, and the word problem states triangle DEF. So it doesn't matter, folks, how you draw your triangle. I'm doing mine DEF. Angle D and angle E are congruent. I'm going to show that by my markings. And from D to E is x plus 4. X plus 4. E to F is 4x minus 8. 4x minus 8. And D to F is 7x minus 35. 7x minus 35. Well, I want to go back. I see that I have two angles that are congruent, so the sides across from those angles are going to be congruent. I'm going to go ahead and put my markings there to show which sides are congruent. Once I know which sides are congruent, I can go back and set up a math equation. 4x minus 8 is equal to 7x minus 35. We have our math equation again. 4x minus 8 is equal to 7x minus 3. Some of you are wondering, well, what are we going to do with this side? Well, we don't know what it's equal to. So what we're going to do is we're going to solve for x. And then we can definitely find out what that side is. So we're going to go ahead and hit pause, work on our algebra again, and see what we get for x. All right, I had to go back and change this. This was actually supposed to be 7x minus 35. So I went ahead and changed that. So once I do all my math and my algebra, I get x is equal to 9. So now what I want to do is I want to go ahead and plug it back in. If x is equal to 9, I'm going to write that here, 9. Then this side is how much? This side is 13. When I plug it back in for my congruent sides, I find out that this side is 28 and this side is 28. So how much is DE? DE is 13, EF is 28, and DF is also 28. So this is how we use the properties of equilateral and isosceles to actually solve problems. The next thing we want to talk about is equilateral triangles. Those are the triangles where we have all the sides are the same and all the angles are the same. So basically, if we find out that all the angles are equal, then we can conclude what? That all the sides are equal. And conversely, if all the sides are equal, what can we conclude? We can conclude that all the angles are equal. So that means angle A is equal to angle B is equal to angle C. And guess what they all are equal to? They're all equal to 60 degrees. All right, let's work on this problem right here. We're given some information that angle A is 60 and angle B is 60. Therefore, folks, all the angles inside of a triangle must add up to 100 degrees, so we can conclude that angle C is also 60. Now that we know that all the angles are the same, we can definitely conclude by our theorems that all the sides are the same. So angle C is definitely 60 degrees. Side BC is going to be 9 feet. And guess what? AC is going to be 9 feet as well. You can take a second to try to solve this one, and then you can hit play to follow along with the video to see if you did it correctly. All right, I read through and I see a vocabulary word, equilateral. What does equilateral tell me? Equilateral tells me that all the sides are equal and all the angles are equal as well. So all I need to do is I need to take two sides. Does it matter which two? No, because they're all the same. So I'm going to take 9y plus 1, and I'm going to set it equal to 14y minus 59. Okay. So once I do that and I solve for y, I find out that y is equal to 12. Now what? Got to solve for x. Well, what is x represented by? X is representing a part of the expression that represents an angle. Because we know all the angles are 60 degrees, we could set this up as 7x minus 3 is equal to 60. Or we could set it up as 7x minus 3, and since it's 3 of these angles, it equals 180 degrees. So we have options on how to set these problems up. However, when we do set these problems up, we will find out that x is equal to 9. This one is definitely a you try. Hit pause and then come back and see how well you did. Alrighty, here's our setup for X and here's our setup for Y. Because we know they're equilateral, all the sides are equal. We're given one value for a side, which is 49, so I use that in both of my problems. Alrighty, let's see what's next. Here we have an equilateral triangle. You can go ahead and hit pause, practice this one on your own, and then hit play and see how you did. Alrighty, so here we have the setup, and you could have set it up either way. You didn't have to use these two expressions. You could have used 6x minus 51 and 4x minus 25. We all get the same answer. We're going to subtract x from each side and get 3x. Minus 25 is equal to 14. We're going to add 25 to both sides and get 3x is equal to 39. Divide each side by 3 and we get x is equal to 13. Alright, this one is a little different. This one is talking about isosceles. They're telling us which sides are equal, wx and xy. I'm going to go ahead and mark it. I always like to mark. This helps me to determine what expressions to set equal to each other. So I'm going to set 6x minus 77 equal to 3x plus 4. I'm going to give you an opportunity to work on your algebra and come back and check and see if you're correct. Here we go. We subtract 3x from each side, and 6x minus 3x is 3x. Minus 77 is equal to 4. I add 77 to each side, and I get 3x is equal to 81. Divide each side by 3 and get x is equal to 27. However, the question says find the measure of each side. So what we need to do is plug it back in. So we have our base is 104 units, and our isosceles, our congruent legs, are both 85. One more practice problem. Here is a word problem. I would like for you to try it, and then after you try it, come back and see if your setup matches mine. Alright, so here we go. I set up my triangle. I marked the congruent sides with tick marks. I translated that to 7x minus 15, which was MK, and then 10x minus 42, which was ML. Solved it, and I got x is equal to 9. And then to find the measure of each side, the last thing you want to do is to go ahead and plug it back in. That will conclude our lesson on day 1, unit 1. Thanks for listening and joining and participating.